Good day to you, my viewer. I am Rhea Alison Madera from 11 Prudence, and today our topic is about compound interests. In this video, we'll be tackling about compound interest. Compound interest or compounding interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. Thought to have originated in the 17th century in Italy, compound interest can be thought of as interest on interest and will make a sum grow at a faster rate than the simple interest, which is calculated only on the principal amount. These are the following terms.
Compound interest. It is usually used by banks in calculating interest for long-term investments and loans such as savings account and time deposits. In this type of interest, the interest due at stipulated interval is added to the principal and earns interest thereafter. It implies that the principal increases over a period of time, resulting to an increase in interest earned at every compounding period. Thus, compound interest is an interest resulting from the periodic addition of simple interest to the principal amount, or simply the difference between the compound amount and the original principal.
P. Principal or present value of F. This is the principal P that will accumulate to F if there is an interest at a periodic rate, which is denoted by I, for N, which is the conversion periods. F. Compound amount, also called as maturity or future value at the end of the term. It is an accumulated amount obtained by adding the principal and the compound interest.
Annual interest rate or nominal rate. It is the rate of interest per year. Term or time in years. It is the amount of time in years the money is borrowed or invested. Length of time between the origin and maturity date. Conversion period or frequency of conversion. It is the number of times in a year the interest will be compounded.
Annually, which is denoted by M is equal to 1, semi-annually, which is M equals to 2, quarterly, M is equal to 4, and monthly, M is equal to 12. I, or the periodic rate, is the interest rate for each conversion period, in which its formula goes as I is equal to R divided by M. N, the number of conversion periods. The total number of times interest is calculated for the entire term of the investment or loan. Now I will be showing you the following formulas to be followed in this lesson. Formulas. F is equal to P multiplied by open parenthesis 1 plus R over M close parenthesis raised to the power of M multiplied by T. Or F is equal to P multiplied by open parenthesis 1 plus I close parenthesis raised to the power of N. For P, we have P is equal to F multiplied by open parenthesis 1 plus I close parenthesis raised to the power of negative N, or P is equal to F multiplied by open parenthesis 1 plus R over M close parenthesis raised to the power of negative M multiplied by T. For our compound interest, which is denoted by IC, it is IC is equal to F minus P. Another formula for compound interest is IC is equal to P open bracket open parenthesis 1 plus I close parenthesis raised to the power of N minus 1 close bracket. For our T, it is T is equal to log multiplied by F over P over M open bracket log open parenthesis 1 plus I close bracket, or T is equal to N over M. R is equal to M open bracket open parenthesis F over P close parenthesis 1 divided by N minus 1 close bracket.
Now, I'll be showing you some following examples of compound interest. First example. Find the maturity values and interest if 10,000 pesos is deposited in a bank at 2% compounded quarterly for 5 years. So we have 10,000 pesos, annual interest rate is 2% or 0.02, time in years is 5, and conversion period is quarterly. So first, we need to find the periodic rate. So let's take the formula I equals R over M, and that's equals to 0.02 over 4, and that turns into 0.005. Now let's find the number of conversion periods. In And to do that, we need to multiply the conversion period and time in years. It's 4 times 5 and turns to 20. Now let's find the maturity value. With the formula F equals P, open parenthesis 1 plus I, close parenthesis N. So it's F equals 10,000, then open parenthesis 1 plus 0.005, then close parenthesis, then 20. So we get 11,048.96. Now let's find compound interest. With the formula F minus P, so that's 11,048.96 minus 10,000, and then we get 1,048.96.
Example number 2. Find the maturity value and interest if 10,000 pesos is deposited in a bank at 2% compounded monthly for 5 years. So our given is P is equal to 10,000, R is equal to 2% or 0.02, T is equal to 5 years, and M is equal to 12 since it is compounded monthly. Our I is equal to 0.02 over 12, which is equivalent to 1.6667, and our N, which is equal to 12 times 5, is equal to 60. So we're supposed to find the maturity value. We will use the formula F is equal to P multiplied by open parenthesis 1 plus I over N. So using the given numbers, we now have 10,000 multiplied by open parenthesis 1 plus 0.02 over 12 close parenthesis raised to the power of 60, in which we get the answer with that is F is equal to 11,050.79 pesos. For our compound interest, since we already have our F, we will use the formula F minus P. So that would be 11,050.79 minus 10,000, and now we get 1,050.79.
Now let's try to find the principal and compound interest. First example, find the present value and interest of 50,000 due in 4 years if money invested is at 12% compounded semi-annually. So we have the given F equals 50,000, T equals 4, R equals 12% or 0.2, M equals 2. Now with the formula R over M, we get 0.12 over 2 equals to 0.06. Now N equals MT equals 2 times 4, that turns to 8. Now let's find the principal value. P equals F slash open parenthesis 1 plus I close parenthesis and N. P equals 50,000 slash open parenthesis 1 plus 0.06 close parenthesis 8. So that's 50,000 divided by open parenthesis 1.06 close parenthesis 8, and that equals to 31,370.62. Now let's find compound interest. So 50,000, then we take the 31,370.62, and that turns into 18,629.38.
Example number 2. What is the present value and compound interest of 25,000 due in 2 years and 6 months if money is worth 10% compounded quarterly? We have our given, which is F is equal to 25,000, T is equal to 2.5 years, R is equal to 10% or 0.10, and our M, which is equal to 4 because it's compounded quarterly. We have our I, which is 0.10 over 4, which gives us 0.025, and our N, which is 4 times 2.5 equals 10. We are to find the principal value, so we have P is equal to F multiplied by 1 plus I, close parenthesis, raised to the power of negative N. In some sense, another formula, which is F divided by open parenthesis 1 plus I, close parenthesis, raised to the power of N, would also give the same answer. Substituting the values, we have 25,000 multiplied by 1 plus 0.025 close parenthesis raised to the power of negative 10, or 25,000 divided by 1 plus 0.025 close parenthesis raised to the power of 10. We get the answer of 19,529.96 pesos. For compound interest, we have IC is equal to F minus P, so we just get 25,000 minus 19,529.96, we get 5,470.04 pesos.
Now let's find the time and compound interest. So with the first example, how long will it take 3,000 to accumulate to 3,500 in a bank savings account at 0.25 compound monthly? Look for its compound rate too. So with the given P equals 3,000, F equals 3,500, R equals 0.25% or 0.0025, then M equals 12. Now with the formula I equals R over M equals 0.0025 over 12. Now let's find the time. N equals log F over P over log open parenthesis 1 plus I close parenthesis. Then T equals N over M. Then that's N equals log 3,500 over 3,000 over log open parenthesis 1 plus 0.0025 over 12 close parentheses. Then it equals to N equals 7,400.00. Then T equals N over N. So that's T equals 740 over 12. It equals to 61.67 years. Now let's find the compound interest. So 3,500 minus 3,000, it turns to 500.
Example number 2. How long will it take for 1,000 pesos to earn 300 pesos if the interest is 12% compounded semi-annually? Again, we have our given, which is P is equal to 1,000, IC or our compounded interest, which is equal to 300, R is equal to 12% or 0.12, and our M, which is equal to 2. Our I would be 0.12 over 2, which give us 0.06, and our F, which is equal to P plus IC minus 1,000 plus 300, which is equal to 1,300. We are supposed to find time. Now we have this another formula which can help us solve for it. We have N is equal to log multiplied by F over P over log open parenthesis 1 plus I close parenthesis, and then T, which is equal to N over M. Now, substituting the values we get from the previous statements, we have log multiplied by 1,300 over 1,000 over log open parenthesis 1 plus 0.06. We get N is equal to 4.503. Then following T is equal to N over M, we have 4.503 over 12, which is equivalent to 61.67 years.
Now with the fourth, finding the rate and compound interest. Now let's look at the first example. At what nominal rate compounded semi-annually will 10,000 accumulate to 15,000 in 10 years? Look for the interest compound too. So with the given P equals 10,000, F equals 15,000, T equals 10, and M equals 2. So that's N equals MT equals 2 times 10 and equals to 20. Now let's find the rate. With the formula I equals to open parentheses F over P close parentheses 1 divided by N minus 1, then R equals I times M. So that's I open parentheses 15,000 over 10,000 close parentheses 1 divided by 20 minus 1. So that equals to 0.025. Then solve for R equals I times M. So that's R equals 0.025 times 2 equals 0.04, which is 41%. Now let's find the compound interest. So that's 15,000 minus 10,000, and the compound interest is 5,000.
Example number 2. At what nominal rate compounded semi-annually will 1,750 pesos accumulate to 2,000 pesos in 4 years? Look for the interest too. So we have our given, which is P is equal to 1,750, F is equal to 2,000, T is equal to 4, M is equal to 2. We have our N, which is M times T, or 2 times 4 is equal to 8. Now we are supposed to find the rate. Now, we have another formula, which is I is equal to F over P raised to the power of I divided by N minus 1, then R is equal to I times M. Now, following the formula, we substitute it as open parenthesis 2,000 over 1,750 close parenthesis raised to the power of 1 over 8 minus 1. Now, we get the answer of 1.68. Then, solving for r, we have I times m, which is 1.68 times 2, we get 3.37%. Now, finding for the compound interest, we have IC is equal to F minus P. We have 2,000 minus 1,750, which give us 250 for our interest compounded. So that would be all for today.
We hope that you learn a lot about compound interest, and we also hope that our lesson will be implemented and benefit your life whether today or the near or far future.
I am Rhea Listen Madera.
I am Asher.
Thank you for watching and may God bless us all.